Voyager 2 has been racing through the cosmos for nearly 5 decades and sending back data that transformed our understanding of the solar system and beyond. But now, as this legendary spacecraft drifts farther into interstellar space, a strange cryptic message has shaken scientists to their core. What could it mean, and should we be worried? For nearly 50 years, Voyager 2 has been hurtling through the vastness of space, sending back revolutionary data that has reshaped how we view our solar system and what lies beyond it. But as this trailblazing probe continues its voyage into the great unknown, it has recently transmitted a baffling and cryptic signal that has left scientists deeply unsettled. What could it signify? Is there cause for concern? An iconic space mission, NASA launched the Voyager mission as a bold attempt to explore the outer reaches of our solar system during a rare planetary alignment. In the 1970s, the orbits of Jupiter, Saturn, Uranus, and Neptune positioned them perfectly for a gravity-assist journey, an opportunity that occurs just once every 176 years. This cosmic arrangement inspired the plan to dispatch robotic explorers beyond Mars to investigate the distant giants of our solar neighborhood. Engineers dedicated years to building 2 durable spacecraft capable of enduring harsh conditions, freezing temperatures, high radiation levels, and violent solar activity far from the warmth of the sun. Timing and funding were essential since the alignment wouldn't recur for generations. The team ultimately constructed 2 nearly identical spacecraft, each with a chance to take a unique path depending on the discoveries made along the way. These probes, compact and robust, measured about 1.5 foot tall and nearly 6 feet across, each equipped with a large 12 feet wide high-gain antenna. These dishes would be critical for long-distance communication with Earth. Voyager also featured a long boom that held instruments for measuring magnetic fields, solar wind, and charged particles. Both carried narrow and wide-angle cameras to document everything from broad planetary views to detailed images of moons, atmospheres, and rings. The 2 spacecraft, named Voyager 1 and Voyager 2, launched from Cape Canaveral aboard Titan Centaur rockets. Despite its name, Voyager 2 lifted off first on August 20, 1977. Voyager 1 followed on September 5, taking a faster route. While spectators sensed the moment's significance, few could have imagined these spacecraft would still be active nearly 50 years later. Their main objectives were to study Jupiter and Saturn in detail, and use gravitational boosts to potentially extend their missions to Uranus and Neptune. Originally built for a 5-year mission, the spacecraft far surpassed expectations and became humanity's most distant travelers, revealing countless scientific marvels. Adding a more human touch, both Voyagers carried the iconic golden records, cultural time capsules meant to portray life on Earth to any distant intelligence. But before those records became historical artifacts, the Voyagers would make stops that rewrote science textbooks. 2 paths, 1 mission. One of the most common questions about the Voyager program is why Voyager 2 launched before Voyager 1. The answer lies in their trajectories. Voyager 1 was placed on a faster, shorter path toward Jupiter and Saturn. Despite launching later, it would overtake Voyager 2. NASA had already assigned names, so they stuck with the sequence even though it didn't reflect launch order. Though constructed with similar hardware, the Voyagers took slightly divergent routes. Voyager 1 was tasked with a crucial close encounter with Titan, Saturn's largest moon. This flyby would redirect it out of the plane of the solar system, preventing any future visits to Uranus and Neptune. NASA prioritized Titan due to hints of a thick atmosphere, possibly unique among outer solar system moons. Voyager 2 was assigned a more extended mission. If it succeeded at Jupiter and Saturn, Mission Control aimed to send it onward to Uranus and Neptune, a long-term plan requiring the spacecraft to function far beyond its expected lifespan. As they launched, Voyager 2 veered southward relative to Earth's orbital plane, while Voyager 1 took a slightly more northerly path. These variations provided distinct viewing angles of the outer planets. Early on, NASA tested all scientific equipment, cameras, spectrometers, magnetometers, and plasma detectors, ensuring everything worked perfectly. Voyager 1 soon reached Jupiter, racing along at over 35,000 miles per hour. Voyager 2 followed a carefully plotted course designed for its extended mission. Both spacecraft were powered by radioisotope thermoelectric generators RTGs, which converted heat from plutonium decay into electricity, a necessity in the dark outer reaches where solar panels were ineffective. Each also carried thrusters for navigation and advanced systems for storing and transmitting data. Though they shared a common design, their journeys were like those of siblings charting different paths on the same grand adventure. These separate routes would define their discoveries and ultimate fates. Exploring Jupiter. By 1979, both spacecraft had reached Jupiter within months of one another. This gas giant provided the first major test of their systems, and the results were astonishing. Their cameras revealed Jupiter's colorful cloud bands, the massive Great Red Spot, and one of the mission's most shocking finds, erupting volcanoes on Io, one of Jupiter's moons. Prior to Voyager's visit, scientists thought Io was a cold, crater-covered rock. Instead, they saw volcanic activity on an alien world for the first time. Io's eruption spewed sulfur compounds, painting the moon in surreal yellows, oranges, and blacks. Another revelation was the discovery of Jupiter's faint ring system, previously unknown. While Saturn's rings were well documented, Jupiter's ghostly rings hinted that such features might be common among gas giants. The spacecraft also imaged Europa's icy surface edged with dark streaks. Later analysis built on Voyager's findings suggested a subsurface ocean could lie beneath Europa's crust, raising hopes for life. Voyager 1's closest approach came in March 1979, collecting vital data on Jupiter's intense magnetic field and powerful radiation belts. It detected lightning within Jupiter's clouds and mapped the extent of the planet's massive magnetosphere. Voyager 2 followed later that year, offering more data on Jupiter's storm systems and confirming Io's volcanic activity. The dual data streams gave scientists an in-depth understanding of Jupiter's atmosphere, moons, and rings. The probes also uncovered new Jovian moons, expanding the known celestial family. After their flybys, both Voyagers used Jupiter's gravity to slingshot towards Saturn, conserving energy and boosting their speeds. Saturn up close. Saturn had long fascinated astronomers with its magnificent rings, but Voyager's arrival provided an unprecedented view. Voyager 1 reached Saturn in late 1980 and immediately began sending back striking images. What looked like solid bands from Earth were revealed to be intricate patterns of icy particles and countless minings. During its flyby, Voyager 1 discovered several moons, Atlas, Prometheus, and Pandora, circling within or near the rings. These shepherd moons appeared to guide and shape the ring structures. By using radio waves to scan the rings, scientists determined they were composed mainly of water ice with some dust. But the highlight of Voyager 1's Saturn mission was its close encounter with Titan. With its dense, hazy atmosphere rich in nitrogen, Titan resembled early Earth in some ways. The flyby gathered key data, but the chosen trajectory sent the spacecraft out of the solar system's plane, making further planetary visits impossible. Voyager 2 arrived at Saturn in mid-1981, flying a flatter trajectory so it could continue onward to Uranus. It verified many of Voyager 1's findings while adding more observations of Saturn's weather patterns. Though less chaotic than Jupiter, Saturn's atmosphere featured powerful storms and fierce winds. A key moment came when Voyager 2 passed behind Saturn from Earth's line of sight, allowing its radio signals to pass through the rings. The resulting data provided insights into ring density and thickness. After Saturn, Voyager 1 began its climb out of the solar system. Meanwhile, Voyager 2 remained on course for more distant, unexplored worlds, into the ice giants Uranus and Neptune. When Voyager 2 set course for Uranus, scientists had little more than blurry telescope images of the planet. No spacecraft had ever visited. The discoveries made at Jupiter and Saturn only heightened curiosity about what lay ahead. In January 1986, Voyager 2 arrived at Uranus. It documented the planet's dim, narrow rings and recorded its extremely low temperatures, around -350 degrees Fahrenheit, making it the coldest planet. Uranus's sideways tilt likely affects its internal heat circulation, contributing to its deep freeze. The spacecraft found 10 new moons, each irregular and scarred from past impacts. Its instruments studied the strange tilt of Uranus's magnetic field, which produced unusual asymmetric magnetic effects. Next came Neptune. Using another gravity boost, Voyager 2 reached the distant blue planet in August 1989. Neptune, though faint from Earth, revealed fierce weather systems, including the massive Great Dark Spot. Winds there reached record-breaking speeds. Voyager 2 spotted Neptune's thin, faint rings and discovered several new moons. Most remarkable was Triton, a moon with geysers spewing icy plumes. Triton's retrograde orbit and geological oddities suggested it might be a captured object from the Kuiper Belt. With Neptune's visit complete, Voyager 2 earned the distinction of being the only probe to study all four gas giants. NASA then powered down its cameras to conserve energy, shifting focus to studying the space between stars. Having completed their planetary missions, both Voyagers embarked on their next epic chapter, the journey into interstellar space.